In this video, we introduce coordination compounds and complex ions. It turns out that the chemistry of transition metals is interesting in part because they can be surrounded by a specific number of ligands and form something that we call complex ions. Okay? Those complex ions have a charge, and they're usually cations, but they can also be anions, and then they need counterions to balance the charge to form something that we call coordination compounds. Right, so here's an example of all this. Think about the following species, which is a compound formed by cobalt, ammonia, chlorine, and more chlorine. Okay, this is a coordination compound formed by a complex ion, which is what you have in brackets, and then counterions that balance the charge, and that is your chloride 2. Right, so these coordination compounds behave as ionic solids. When you put them in solution, they dissociate to generate ions, and what they form is well, these two chloride counterions dissociate as 2Cl- in aqueous solution, and then the rest, the term that is in brackets, is a unit, which is what we call the complex ion. Now, you can find out what the charge of that complex ion is by noticing that the overall coordination compound is neutral, and if you have two negative charges right here, that means that the charge in this complex ion is 2+. Right? So then the complex ion is formed by an interaction of cobalt and 5 amine molecules and chloro ligand. These molecules right here are called ligands, and that is the transition metal. And then you can see that again, that would be a complex ion formed by a cobalt 3+ ion, then 5 amine ligands, and then a chloro ligand, which carries a negative charge. That's why the charge of your ion is 3+, but the charge of the overall complex ion would be +2. Okay? Right, so again, as we have said before, you can have here that the complex ion has positive charge, and sometimes you have negative charge. And in the next video, we'll learn how to name those complexes. They have a slightly different nomenclature depending on whether they are cations or anions. Right, so for now, we're just going to be more interested in trying to figure out how the bonding is between this transition metal and the ligands. Right, so it's often the case that the transition metal behaves as a Lewis acid, and then the ligand behaves as a Lewis base. All right, the definition of a Lewis acid is a substance that can accept a pair of electrons, and the definition of a Lewis base is something that can donate a pair of electrons. Right, so in this particular case, what happens is that the bond is formed by these two electrons of the ligand, okay, being shared with the transition metal to form something that we call a coordinate covalent bond. Okay, this is different from a straight covalent bond, in which you have that the sharing of electrons is provided by both atoms that are forming the bond. In this case, is the ligand that is provided both electrons of the bond to generate, again, a coordinate covalent bond. Okay, so when you're thinking about what are good Lewis acids, transition metals that are positive ions tend to have empty d orbitals, and that makes them pretty good Lewis acids. And then for ligands, you're just simply looking for molecules that have lone pairs, and there's many of those, right? So here's an example, or many examples. Here you have that ammonia, obviously has a lone pair. Then water, you can also have lone pairs and act as a Lewis base. Okay, but there's many more. You have here this cyanoligand, then you have isocyanate, hydroxide, and then the halogens. All those have lone pairs that can actually form this coordinate covalent bond with a transition metal. Okay. Now these are all what we call monodentate ligands, in that they can only form one bond with the transition metal. But there's special cases of ligands that can form more than one bond for the same molecule with a transition metal. For example, take a look at this ligand, which is called ethylene diamine, NH2, CH2, CH2, NH2. Notice that here you have two nitrogen atoms, and in the Lewis dot structure you have one lone pair here, one lone pair here in the same ligand. So both of those can actually form one bond with a transition metal, and this will act as a bidentate ligand. It's also called a chelate. Okay, so that will be a polydentate ligand or a bidentate ligand, and then there can be tridentate, tetradentate, and polydentate ligands, in which again you establish more than one coordinate covalent bond with a transition metal. We're going to refer to this ligand as simply En for simplicity. Alright, so to summarize this video, we simply have provided here an introduction to coordination compounds and the complex ions that form them. We have seen that the way that these complex ions form is simply by a coordinate covalent bond, which is formed by the interaction of a Lewis acid and a Lewis base. In the next video, we're going to learn the nomenclature of these ions, which turns out to be quite interesting.